All my money. The brownies are too small this time. Tell them to make the brownies the size of the pan. They don't give you like $10.
Just for breakfast.
5 to 10, maybe 6. Huh? It was wrong. $1, right?
Yeah.
Yes.
I don't need.
Hi, Denver. Can I
Oh, Lord. Okay. All right, here we go. So you're going to split them up. You have x squared plus 1 equals 0 and x plus 7 equals 0, right? So negative 7 is one of them. And x squared equals negative 1 square root. And what is my answer? Technically,
Yes.
yes. Technically, no. Technically, it's plus and minus I, right? Who's that? Somebody like Deanna. All right, now look. If you were to go and group number 8, they would not group out to be the same things, right? So when you go to y equals, which is what I told you to grab your calculators for, go to y equals, plug it in. Hit graph. Do y'all remember having to do these? This craziness? So let's see, this one looks like it hits at, what is that, negative 5? Negative 5? Okay, so we're going to put negative 5 in our cute little box, right? And we have 1 for x cubed, 1 for x squared, negative 17 for x, and 15 is our constant. Long division. Or synthetic division.
Why would you use negative 5?
Because it's the one, it's the easiest one to see. It's on the left-hand side over here. Just go with the one on the left. It normally, the one on the left normally makes your life much easier. So just go with the one on the left. All right, so let's do this real quick. Bring it down, multiply, bring it down, multiply, bring it down, multiply. Oh, negative. And remember when you did these, you were always supposed to get 0 as a remainder, right? So we know we have x squared minus 4x plus 3. And we have x plus 5, right? Oh my gosh, where did I get the x plus 5 from?
switch the sign of things?
You switch the sign of this one, right? And so now you can factor this. What are the factors of 3 that add or subtract to be negative 4? 3 and 1. Just bring that x plus 5 down. And what kind of signs will give me a negative 4, but multiply to give me a positive 3? 2 negatives. And so what are my zeros? 3, 1, and negative 5. Just bringing some memories back? Okay. Oh, Lord Jesus. Number 9 is a beast. Okay. All right, so let's go to y equals. Let's plug it in.
Wait,
Yes, dear.
go back.
Yes, I can.
Never mind.
You sure?
I see what I did wrong.
Okay. All right, so let's plug in this one. All right, so we're going to look on the left-hand side and see which one. Normally the one on the left is easiest, okay? What's that look like that it hits at? Negative 3? Is that the only one? It's still thinking. Hold on. Mine is anyway. Yep, it's done. That's the only one. So negative 3. All right, so let's do negative 3. Am I missing any exponents? Nope. So I got 1 for x to the 4, 6 for x to the 3rd, 73 for x squared, 384 for x, and 576 for my constant. Are y'all okay? Okay. Alright, let's see. Bring it down, multiply. That's gotta be 576. Yep. Alright, so let's see, I have x to the third, 3x squared, 64x, 192, and then x plus 3. Are y'all okay? Let's see if that'll factor. Yep, okay. So let's do, what do the first two have in common? X squared, there you go. That'll be x plus 3. What do the last two have in common? 60, plus or minus? Plus. So that's x plus 3. And just bring down this x plus 3. I just put brackets around it to make it look prettier so I can tell it apart. Y'all okay with that?
Yes, ma'am.
What's wrong, Brinkley?
So this isn't the one where you do like x squared plus 64 and then x plus 3.
It is.
You do cube.
It is. It's x squared. You're right. I just hadn't finished it yet. I was giving y'all a minute. And so then these two I can put as squared.
So you can't put the third one with them?
What third one?
Because there's a 2x plus 3 and there's x plus 3.
No. This, pretend like that's not there. Pretend like all you have is in the brackets. This is what they have in common, so that's why it gets pulled together.
Okay.
Because when you multiply this all back together, it'll still give you this x cubed plus 3x squared plus 64x plus 192. Alright, so I can cut them. This is just x equals negative 3. This is x squared equals negative 64. So then when I square root, once I square root, 8i. There you go. Perfect. Good job, guys. Very good job. Look at y'all. I'm so proud of y'all. Just took a little, pull in a little bit, and you remembered. So good. You're going to need it, guys, okay? You're going to need it for pre-cal. And you're going to need it for the next couple of days. All right, here we go. Here's what we're going to do. Grab your HCT packet, and we're going to do 6 through 10 in 4 minutes. Don't cheat and look at it yet. Don't cheat. I'm just saying, you're just cheating yourself if you do it, okay? And no, none of my perfect little angel babies have ever cheated.
Angel babies.
That's never happened before. Yes, ma'am.
I don't have the sheet yet. Like, the other day I was using 2 sheets and you said we would cross that bridge when we came.
And you didn't come back and tell me to cross that bridge.
Well,
So you're missing the second. You're missing the second page.
Yeah, I've got through 7, but then I don't have 10, but I've got.
Okay, got it. There you go. You're welcome. Is it hole punched?
Yes.
Okay. All right, everybody ready? Everybody get their stuff out? Next ACT is February 11th. For 11th graders, you will be taking the ACT at school come April, right? I don't remember the exact date, but it'll be April. Then, if you're taking it on your own, then you can take it again April 8th, right? So really, there's no point in there's really no point in paying for it in April since you're gonna take it in school April. But if you haven't taken it very much, you probably should take it. There is another one in June. Yes, Thompson doesn't give that one, but I know Clear does, and I think Pelham does.
Well, they come.
All right, here we go. You ready? 4 minutes and go. 4 minutes. 6 through 10. Stop at 10. Seconds. All right, time's up. Okay, so what's your homework tonight? So look at to check them on Google Classroom, right? Check your answers, and then tomorrow we'll come in and tomorrow we'll come in and we will go over any questions that you have. It's the checkpoint. All right, now let me tell you a funny story. You ready? So yesterday morning, I had a sweet little friend of mine come in here, bless her heart, and she wanted to help me. So I said sure, because she had nothing else better to do. And I told that person, I'm like, I need this cut in half and printed front and back. They're like, okay, we can do that. She didn't do that. And I realized it as y'all were walking out the door yesterday. So what you have in front of you is your actual checkpoint that you were supposed to get yesterday. That was supposed to be front and back. So only gave then hand one to Elizabeth. You have one? Okay, never mind. All right. So here's the deal. You ready? Look at the top section up here at the very, very top. The very, very top says function operations, okay? That's what some of you, unfortunately, got yesterday. Then at the bottom, it says composition of functions. A few of you got that one yesterday. Does that make sense to everybody? So you only got half of what you were supposed to get. No, you don't have to rewrite it. Just staple what you've already done to this one and just do the other one that you have done. Does that make sense to everybody? Is anybody lost? I am terribly sorry about that. This is why I do things myself, okay? All right. So just make sure, if you want to just throw away the other one and write it on here and have it one place, that's fine. Or if you just want to staple it together, I don't care. All I'm worried about is that you get it finished, okay? So we have to finish a lesson today. And once we get that finished, then we'll go through and have some time to do checkpoints. Everybody good? Tomorrow you have a quiz. You cannot take the quiz until this is a 100, right? But that top part should be extremely easy, and the bottom part should be pretty easy too, right? That stuff yesterday was not too terribly bad. If you were absent yesterday, you have a 0 period that you could come in today. You have 0 period that you can come in tomorrow. You just come get some help. Come say, hey, did I get this checkpoint right? And all that good stuff tomorrow. Okay, is everybody good? Anybody lost? Yes and no. Depends on what we get finished today. It's looking like it's probably going to be more like Monday, but yeah, that too. So yeah, we'll see. Let's see how much we get finished today, and then we'll go from there. All right, here we go, guys. You ready? Let's grab our notes, and we are on page. Yesterday. Let's look at page 5. This page right here. Make this smaller so I can see it. Alright, so if you haven't already labeled it, make sure you label it page 5. This is just extra problems. We are not doing this. These are extra problems down here at the bottom if you need some more help on adding, subtracting, multiplying, or dividing. Mainly the dividing one, as I know what a lot of you have. We are not doing this page. But if you need some extra problems, or if you want to put this as, hey, these are good problems to study for my test, or hey, these are good problems to study for my quiz, 1 through 5 are some awesome problems that you can use to study, okay? All right, so let's look on the back of that. The back of that is the lesson we are starting today, and it is page 6. So if you haven't already, go ahead and label that as page 6. It says lesson 6-2 at the top of it. That's page 6. Okay, it's pretty easy. If you had me for Algebra 1, we have done this particular 2 problems before. And actually 4 problems before. And if you didn't have me for Algebra 1 and you don't remember this, then we are about to go over it again. You should hopefully remember it from Algebra 1, but I know for some of us it has been a minute, especially if you had Algebra 1 in 8th grade. Alright, you ready? Inverse. What in the world do you think the word inverse means? Because it says find the inverse. The opposite, right? So all you do, this is a relation. How do I know it's a relation? Because it has the little curly brackets, right? Ooh, that's been since like the first 2 weeks of school that we've talked about relations, okay? So we know it's a relation because it has the curly brackets, and all you do is switch the x and the y. That's what inverse means, okay? So you do 10 and then negative 9. Don't switch any signs, just switch their places. Negative 3, 1, and negative 5, 8. And that's your inverse. That's it. Is everybody okay? Pretty easy, right?
So we have to do the colored bracket?
Yes, sir. That's the representation of a relation. That's a set of numbers.
Wait, then why wasn't it in 8th grade yesterday? You were talking about was Jake.
A J.
Jake?
Oh, Jake. Yeah.
That
Because when he moved from his other class, they did domain and range as set notation, which is why he had curly brackets around the way he did domain and range. We don't do it like that because when you get to pre-cal and to calculus, they want interval notation, which is the way we've been doing it, more than they want set notation. So that's why I teach you interval notation. That way you'll be used to it by the time you get to pre-cal. So, well, that's awesome. Thank you. Okay. So all we do here is just switch them, right? So you do 9 and negative 2, and negative 1 and 4, and 9 and negative 7, and 0, 7. Ridiculously easy, right? Same thing on the bottom two, except now they give you functions. So what's the difference in a relation, which is what the first 2 were, and a function, which is what the bottom 2 are? Because of the equal sign, right? And a function, I know is a function. Relations, I don't know if they're functions yet or not. So let's look at number 1. Is number 1 a function? How did I know if it was a function? Not f of x. Somebody said something in the front, I just couldn't hear it. The x's don't repeat, right? It's okay for the y's to repeat, but the x's do not repeat. So that's why this is a function. So I technically could call this a function. And what about number 2? It is a function. That's 7 and negative 7. They're not the same thing. So that is a function.
Wait, you said the x's, right?
The x's could not repeat.
Well, the inverse.
No, not the inverse. We were looking at the first one. Now the inverse would not be a function, and that has a special meaning too. But we'll talk about that later. All right, so let's look at this. Instead of f of x, we can write y equals 2x minus 5, and we do the exact same thing, except now we don't have numbers. You literally change y to be x and x to be y. And then to be a function, what does it have to be solved for? Y. So I have to take this inverse and now solve it for y. How can I solve this for y? You add the 5 to the other side, should be x plus 5. Then what would I do? Divide by 2. And this is the inverse. So instead of putting equals y, do you remember what the symbol for inverse was? We did it when we did the matrices. Where's the negative 1 at? Very good, very good, very good.
Wait, you just put it over the y?
Yep, because that's the inverse. Now that's the y. I can. If I want to be real technical, I need to put it back the way. Now, I will accept this, guys. This is correct. But if you want to be real technical, you need to put it back in the f of x form. So it'd be the inverse is equal to x plus 5 over 2. Either one is correct. This one is the actual technically correct one. I'll accept either one right now, though.
Which one will be on the ACT?
This one. Which is why I'm showing it to you. All right, same thing on number 2. H of x is the same thing as what? Y. And you literally switch the x and the y. On the first ones, we had actual numbers of x and y. This one, we don't have numbers, we have letters. So instead of y, we put x. And instead of x, we put y. Now, I need to find y. I need to solve that for y. So how would I do that? Multiply by 3 on both sides. And 3 times x is just 3x. And now what would I do? Add the 4. And I'm not going to say y. I'm going to say that's the inverse. And if you want to be super duper correct, oh, not f, excuse me, that's h. It's h of x. So inverse means opposite, right? Well, what did we start off with right here? What kind of operation is between 2 and x? Multiplication. Guys, what's the opposite of multiplication? Isn't that what we ended up with? What's the opposite of subtract 5? Isn't that what we ended up with? Alright, so here we ended up with what 2 operations? Division and subtraction. I should have the opposite of those down here. Do I? Yep, multiplication and addition. Y'all okay? Alright, here we go. Let's flip over to page 7. And
Wait, so what's a real life problem where you would need inverse?
inverses is a lot to do with weather. So if you want to be a meteorologist, they do a lot with weather in inverses. Mainly because the only one I can really think of right now is like tornadoes. Something about the wind velocity is directly related to something else. Anyway, meteorology, you'll do a lot of stuff with inverses.
Ask Mr. Long.
Mr. Long would be a good person. Yeah. All right. So I want y'all to quickly go through 3 and 4. 4 is a little different, but it's still the same process. And then we'll go down to the bottom 2 problems and go from there, okay? 3 and 4, real quick, like. Let's look at these real quick and see what we got. You ready? Most of us just got stuck with this fraction. Okay, right here's where we got stuck, right? You do not divide by a fraction. One fraction's bad enough. You divide by a fraction, you're going to make 2 fractions, and you're going to make a big hot mess of a fraction, right? So how do I get rid of a fraction? It starts with an R. Reciprocal, right? So you're going to do the reciprocal, which is 3 over negative 5, like that. All right, now the thing is... What?
Oh, never mind.
You sure?
Yeah, man, I got you.
Okay. All right. Now, let's make this one big fraction, okay? So this would be 3 times x plus 8. Yes, you have to use parentheses because that is times all of it. And that negative 5 is on the bottom. That's my inverse. Because remember this x plus 8 is really over 1, right? Now, the way you're probably going to see this is you're going to see the inverse of f of x. You're going to see this negative put out to the front. More than likely, you're going to see the negative out to the front like this, then your fraction. Does that make sense to everybody? All right. You know what I'm talking about with standardized tests? Have you seen them out to the side like this? Okay. And then you're probably going to see this 3 distributed. So that'll be 3x plus 24. They could leave the 3 and then x plus 8, but more than likely they'll distribute it. So that's your answer. All right, what about 4? Most of us had already started on 4, and we're doing a pretty good job on that one. X minus 4 equals y squared, right? Square root it, perfect. And so x minus square root of x minus 4 is the inverse. Since this is a function that we're talking about, we won't do plus and minus right now. So because it's a function, x minus 4, and so we'll have the inverse of g of x is the square root of x minus 4. And we are getting very close to learning how to graph square roots. We're getting very, very close to that very soon, okay? Y'all feel pretty comfortable about this? This is going to be on your quiz. Probably more like a quiz on Monday, okay? If I had to guess. All right, let's move. Checkpoint is just due before you can take the quiz. I don't really care when you turn it in. You just can't take the quiz until I have it in as 100. So if you need 2 weeks, then you take 2 weeks. I wouldn't really suggest that, but because then you're going to get behind on other stuff. All right, let's move down to the bottom. Down at the bottom is where you're going to need to remember the composition stuff that we did yesterday, right? Remember that, what we did? Okay. But I think y'all did pretty well on that yesterday. And if you weren't here yesterday, this is a good time to get caught up. All right. So, well, I went too far. Let's look at the directions. What do the directions say right here at the top? Okay. So we have to determine if they're inverse functions, and we have to explain why they're inverse functions. So these two are probably going to be where we finish. We'll finish up the rest of our notes tomorrow. So we're probably looking more like a quiz on Monday, okay? Does that sound good to everybody? Is everybody good? Would you rather have it on Tuesday? The only thing is if you do it an extra day, I won't be able to get it graded as fast, but it's up to you. Well, Monday sounds great? Okay. All right, cool. So let's look at number 1. Number 1, first thing that we have to do is we have to find compositions. Now you're like, yesterday we really didn't have time to talk about this. But you're like, where in the world would we use this crazy hot mess called composition stuff, okay? If the best example that I can think of is if you are a real estate agent or if you are a car salesman. Then when you do rebates, like you've seen when they sell cars, they'll say, if you come by it now, you get 0% APR and $1,500 rebate or something, right? Have you seen them say that before on commercials? That rebate makes a big deal about when it's applied. If they apply the rebate first before they apply your percentages, it makes a big deal. And if we have time on Monday, we'll do a problem so that I can show you what we're talking about, okay? Does that make sense? All right, so let's look at this one. First thing you have to do is you have to look at F composition of G, and you compare that to G composition of X, or G of F of X, or F of X of G of X, whatever way you want to say it. Compositions, it's just easier for me to say compositions than it is for me to say G of F of X. All right, so what does this mean? This means that we're going to take G of X and we're going to plug it into F of X, right?
Yeah.
Okay, what is G of X?
1 over 3x plus 1.
Okay, and that is going to go in the place of this X right here, okay? So here we go.
Wait, do that little example again? Alright.
Uh-huh. G of X right here, 3x, 3 over x, 1/3 x plus 4. Excuse me if I can get my words out. That's going to go in the place of x in f of x. So instead of x, I'm going to put 1 over 3x plus 4. And then minus 3. So this is still 3x minus 3.
Wait, where did you get the 3 from? I'm sorry.
What 3, baby?
Like
This one? Or in front of it? Because right here, 3x minus 3. This is still 3x minus 3. Yep. All right, distribute right here. 1/3 times 3 is just 1x, right? Or x. 3 times 4 is 12 minus 3. And so that is x plus 9. And we have to compare that to what we get for the other one.
Wait. How is 3 times 1/3 x?
It's 1x. 3 times 1/3. The 3's cancel out. And you just get 1. Now, I really don't even have to finish this. If it's okay with y'all, we're not going to finish this, because what you're looking for is you have to get the parent function. What is the parent function of x plus 9?
It's a regular mx plus b.
It's a regular mx plus b, but in this case, what would it just be? What is just the parent graph? What is just the part that goes through the origin? Y equals what? If you need to, get out your parent graphs.
Y equals x.
Y equals x, right? Y equals x is just the parent graph. Why is this not the parent graph? Because what does this plus 9 do? It moves it up 9, right? From the origin. So since this did not come out to be just an x, these are not inverses. You may want to make yourself a note. Since you didn't get just x, and it even says explain, doesn't it? It does say explain. So we're going to say not inverses because our answer is x plus 9, and to be inverses, you must get just x. Does that make sense, guys? Kind of. You have to just get x. I'm going to show you in just a minute on the calculator what happens, because I think we'll have time for that. All right, let's look at number 2. Here we go. So let's do the first one. F of g of x. We don't have to. Since this is not x, since this is x plus 9, I automatically know they're not inverses. All right, so let's look at this one. Seeing as how the first one was not inverses, if I were a betting person, I would bet that this one's probably going to be an inverse. If I did my notes correctly, which I'm pretty sure I did. All right, here we go. So we're going to plug in g of x. Yes, ma'am.
Okay, so the two ways you wrote the g of f and the f composition, you can write it either way.
Yes. This one just makes it easier for my brain to figure out which one goes where. This is why I rewrite it.
Oh, that's what that is.
Yeah, they mean the same thing. This one is just easier for me to figure out because my dyslexia is bad enough as it is. So we're going to plug in this g of x right here, this whole conglomeration, into x right here. Ready? Here's a cool thing that happens. Watch, here we go. So you got 2 first. Then instead of x, I'm going to put g of x. Hold on, don't freak out yet because something cool is going to happen. Then it is squared. So they cancel out, right? So you don't have to worry about it. This square root and this square cancel out. So I have 2 times x plus 1 over 2 minus 1. And what happens again? The 2's cancel out. And what happens again? The 1's cancel out. Now, I can't assume that it is inverses yet, because I have to check the other one to make sure that that one becomes an inverse, correct?
Mm-hmm.
All right, so we're on a pretty good start, though. Since we got the inverse, since we got the identity function, then we're pretty good so far. Let's check the other one. Am I going too fast? A little bit? Okay, I'm sorry. Good now? Okay. All right, here we go. Let's try the other one. Now remember, you don't always get the same function when you do them both ways. Remember that from yesterday? All right. So, now we're going to take f of x and we're going to plug it into this little bitty x right here. We're going to take all this hot mess right here, plug it into here. So we have square root but I'm not going to put x. I'm going to put f of x, which is 2x squared minus 1. And then after that is plus 1 over 2. Whew, that looks like a hot mess right there. All right, let's see what happens. Do you see anything that cancels out so far?
Yes.
The 1's cancel out, right? Bless you.
And then the 2's.
Uh-huh. Well, let's do it in 2 steps for some people that can't see that. Bless you. And you are correct. The 2's do cancel again. And what cancels out, somebody saying? Square and square root cancel out. So what you got?
X.
I just have x. So these are inverses. You have to put y. What's my answer? Because what? Because both your answers are the identity function x. I just squeezed all that in. Sorry, guys. Just didn't have enough room. Are y'all okay? For real, for real? Y'all okay? Okay. Let's look at my calculator. So y'all just chill out for a few minutes. And let me plug in and show you what happens. You ready? So what was it? 2x squared minus 1. Is that right? And then we have square root of x plus 1 divided by 2, right? Okay, so what was the whole point of this? What were we supposed to get as the identity function of inverses? What were we hoping to get each time? X, right? So let's see, x is going to be that black line, and the other two are going to be red and blue. So let's see what happens. Ready? You watching, or are you too busy packing up? There's the first one. There's f of x in blue. There's g of x. Okay, so what has happened, if you can imagine this blue line right here, when you flip it over this black line, it's going to make a parabola, right? Do you see this red line that makes a parabola down here? But why can I not have this bottom part of a parabola when I turn it sideways? What's wrong with this down here? It's negative, and what can you not have in a square root? A negative. So that's why they're inverses. When you take that graph and you flip it over y equals x, it becomes the inverse. Does that make sense to everybody? Okay, while you're packing up, I'll do the other one for you if you want to watch that one. Go ahead and pack up real quick. You got about 2 minutes left. See, there's the first one that we did. You see that crazy hot mess? None of them are opposites. You can't reflect one over the other one and get the same thing. All right, so tomorrow we are going to finish up what we didn't finish today. We got a lot to do tomorrow, and then we'll have a quiz on Monday, okay? Does that sound good? All right, so here's what we got right here. Look at this next page. This is page 7. Don't move, don't move, don't move, don't move. This is page 7. These are awesome problems if you need to work out some extra problems if you're having issues, okay? It's not homework because you got a homework coming up on Monday. Y'all have a great day.